kung tama inyong answer. Okay, quiz number 1 for prelim. Let's have compute for the molar masses of the following. So, depende sa inyo ha. If you have memorized the atomic weights of the elements, then this will be easy. Pero pag wala, then you need the help of your calculator for this. Okay, let's have the first one, sodium bicarbonate. So, let's have sodium bicarbonate, sodium, hydrogen, carbon, and
Oxygen.
so sodium isa kabuok, hydrogen isa, carbon isa, and tatlong oxygen. Let's multiply each with their atomic weights. So
23.
is 23. The instruction is to round off the atomic weights to the nearest whole number, no?
Yes.
1, carbon is 12, then is
16.
16. So this is 23,
23.
1, 12, and 48.
48.
So all in all, this is 84.
84.
Okay, the correct answer here, do not forget the unit.
Per mole.
Grams per mole. This is for number 1. Now for number 2, how do you read ZnF2?
Zinc fluoride.
Okay, very good. Zinc fluoride, zinc and fluorine. So you have 1 zinc and 2 fluoride. What is the atomic weight of zinc?
65. Charot.
65. Okay. So this is 65.
19.
And 19 for fluorine. So this is 38. 65 plus
103.
38 is 100
103 grams per mole.
Okay. Now for number, this should be letter A, sorry. This is letter B and
B.
letter C. So KNO3, how do you read KNO3?
Potassium nitrate. Nitrate.
Okay, potassium nitrate. Okay, potassium nitrate. Lesser na oxygen, that's the time nitrite siya. So KNO2 is nitrite and KNO3 is nitrate. So isa ka potassium, isa ka nitrogen, and tatlong oxygen. So what is the atomic weight of
39.
39? So this is 39. And then 14 for
14.
nitrogen. And for oxygen, we have 16.
48.
So 48 again. 39 plus
101.
plus 48 is 101 grams per mole. Now let's move on to letter D. What is letter D class? Aluminum chloride. So what is the atomic weight of aluminum?
27.
Okay, so this is 27, and for chlorine
35.
35. So this is 105
132.
plus 27. The correct answer is 132 grams per mole. How about letter E? How do you read the name of letter E?
Ammonium. Charot. Ammonium hydroxide.
Okay, ammonium hydroxide. NH4 is ammonium, plus ammonia is NH3. NH and O. You have 1 nitrogen, 5 hydrogen. You have 4 here and another 1 sa last and 1 oxygen. So this is 14.
116.
So all in all, this is 35 grams per mole. Okay. That's for number 1. Walay kurat ang molar mass. Other name for molar mass is molecular mass or formula weight. Parehas lang yan sila. That's how you compute the molar masses. Now let's move on to number 2. The question is, Determine the mass in grams of lead ion if in 15.0 grams of lead sulfite. Sulfate, sorry. Sulfate. Kailangan nato mabalaan ang mass in grams of lead ion in 15.0 grams of lead sulfate. So the first thing na himuon nato is to compute for the molecular weight of lead sulfate.
Sulfate.
Okay? So before you can compute, dapat kabalo ka sa iyahang molecular formula. So lead sulfate is
SO4.
PbS4. So PbS and oxygen.
Oxygen. 207.
207 ang lead. Tama?
Yes, ma'am.
114,
It's
207. And sulfate, ay sulfur.
32.
Pila?
32, ma'am.
32. And this is 16.
16, 64.
64. So all in all,
303 grams per mole.
okay, 303 grams per.
Per mole.
Pagkabalo na ta sa molecular weight, first we will be computing for the moles of lead sulfate. So do not forget that the formula is moles is
Weight of substance over molecular weight.
okay. So weight of substance, the given weight is 15.0 grams. The
Zero.
molecular weight is 300
303 grams per mole.
So makancel ang grams, you will be left with the mole. So 15 point,
0.0.
okay. Let's copy everything. 0.04,
950.
04, 9,
4,
5.
950.
Pwede po siya. Ulit-ulit niya siya. So, ano siya continuous. So, pwede na siya mole diretso. Next, if we know now the mole of the whole compound, then we can compute for the lead. So, lead na lang ta. So, the same formula, but you will be using the computed moles. Yan, you will be using the computed mole, which is this one. And then we will be computing for the weight of the substance. Now, for the molecular weight, this should be specific for lead. We only have one atom for lead, so you'll be using the 207 grams per mole. So cross multiply, weight is equal to, makancel ang mole, kay multiply nato na siya, 207. Pila?
10.2475 grams.
Okay. My instruction is 4 decimal places. So 2475. So this is the final answer. Okay? Question sa number 2? Wala. Okay. So let's move on sa number 3. Determine the number of moles and millimoles of sulfuric acid in 4.0 grams of the pure acid. Okay, so this same formula, before you can compute for the moles, ay sa millimoles class mo, agi sa ka sa moles. So moles is equal to weight over molecular weight. So the given weight here for the acid is 4.0 grams, but the molecular weight is not given. So you have to compute it first. So pag sinabing sulfuric acid, that is H2SO. So you have H, S, and O. Duha ka hydrogen, isa ka sulfur, and apat ka oxygen. So this is 1. Pila gani ang sulfur? 32.
16.
16. Sorry.
64.
64. So all in all, you have
98 grams per mole. Puti.
98 grams per mole. Makancel ang grams. The answer here is 4 divided by 98.
0.040816.
Okay. Pwede na to siya i-ano, iputol na lang. 0.048 mole. Sige, answer ninyo the whole thing.
Yes, ma'am.
Okay, that's okay. I have no problem with that.
Puti.
So, putlon lang sa nato siya dire. And then, what is our, mag-compute na tag millimoles, what is our conversion factor? Okay, okay lang din kung 4 decimal places. No problem with that. Our conversion factor sa isang mole, you have 1,000
1,000 millimole.
millimole. So, makancel ang mole. This is times 1,000. So, the answer here is 40.81 or pwede na to siya i-4 decimal places.
8163.
83 millimole. This is the final answer. Okay? Questions? Kaya lang, moles, millimoles, and then, actually, this one is stoichiometry, and then molar mass. Again, number 1 question, discuss the process of cleaning the laboratory apparatuses. Do you know, third year naman mo, so, dili man mo first year, nakahuman na mo pila ka buok nga lab. So, what is the correct process of cleaning our glasswares? Si answer ninyo dito.
Pinaka-first jud ma'am, di maghubog gloves. Guilty mi anak.
Okay, do not forget your PPE, personal protective equipment. Di ka maghubog maayo gloves kay paano kung acid ang nakabutang sa imuhang glasswares and then hugasan nimo siya with your bare hands. Corrosive ba yan ng acid? So, pwede siya makasunog. So, you have to protect yourselves. So, sunod. Mo HCl pa jud. Afatay. Kamatay. Mas problema na to kung bases. Kaya di ba bases can cause liquefactive necrosis. Si acid, siya, magkiloid good siya, siyang noun. Pero kung bases ang maadto sa imuhang skin, it can cause liquefactive necrosis. Matunaw na imong kamot. Mo na siya ang problema. Mo na nga mag-PPE jud. Okay. Now, the correct process jud of cleaning the laboratory wares is first, you have to clean it with hot detergent. Again, take note of that. You have to clean it with hot detergent followed by tap water, meaning i-rinse mo siya with with tap water. And the last thing na imuhang ihugas sa iyaha can be deionized water or distilled water. So before na to siya i-keep sa storage. That's the correct process of cleaning our laboratory wares. So I don't know if hinahimo ninyo na siya sa lab. Basin tap water lang taman. So, mabilin to whatever is the contaminant sa ato ang tap water, mabilin to siya sa atong glasswares and makakos siya og variations or interferences during the analysis. When you say interferences, it's any substance that can cause error sa analysis. So, sa QC, since we are talking about quality, we have to make sure that the glasswares are thoroughly cleaned and walay mga interferences, walay mga contaminants na naa sa even sa glasswares lang. Okay, that's the correct answer for number 1. And then number 2, why is drying the interior surface of glassware before use not really necessary? Sa answer ninyo dito sa assignment. Nung dili man necessary na you have to dry the interior surface of the glassware before nimo siya gamiton.
Ma'am,
Yes.
sa ako lang na research, ma'am. Kay dili pud ko sure, pero ang akong na research, ma'am, is kapag gamiton ang glassware No need na siya i-dry before use. Kay pwede gud siya i-ano ma'am, kanang i-conditioning nga butangan sa nimo og kung unsa nga chemical ang imong ibutang dito sa aparatus, mao to ang gamiton nimo nga panglimpyo.
Okay.
Kumbaga.
Yes, that's correct. Okay, aside from that, that is correct ha. Like sa pipette class, we cannot really dry the insides of the pipette, no? So when we clean it, we use the same substance that we are going to use during the analysis. Like kung gusto ka HCl imuhang i transfer or i-measure using the pipette, then you clean first the pipette with the HCl. That's how you do it before use. So no need to dry. Aside from that, what else? What is the reason why we don't need to dry the interior surface of the glassware? Any other answers? Before nako ihatag ang answer.
Yung akin, ma'am, ang na-search ko is to avoid any contaminant, ma'am.
Okay, that is also correct. Kasi when you dry it, you can, some students will use tissues or you can use cloth, but remember that it can be a possible source of contaminant na ma-add dito sa imong glassware, and then it can cause error sa imong analysis. So actually class, drying the interior surface of the glassware is a waste of time. You don't need to place it inside the oven for it to dry. Dugay kay mahuman, dugay kaayo ma-dry. Or you don't need to wipe it with tissue or cloth because it can be a possible source of contaminant. So pwede niyo na siyang gamitin, especially when you use distilled water or deionized water when cleaning it before storage. Pwede na siya gamiton kasi most of our solvent kay water man jud. So dili siya ing ato nga mag-cause og error jud sa analysis. At the same time, before using, you can wash the interior surface or the insides with the same solution that you are going to use sa experiment. So, ana siya. Next, enumerate some chemical substances that can be used in removing grease films in laboratory apparatuses. These are basics in the laboratory. I just want to know kung ginabuhat ninyo siya. So, pag naay wait lang, may answer pala sa chat. Yeah, okay lang siya dili i-dry as long as dili siya maka-affect sa concentration sa final solution. That's correct also. Now, how about number 3? Okay, Blesil, tama yan siya, acetone. What else? But you cannot buy acetone sa market na dinaghan ha. Di ba ang acetone ginagamit na to siya in removing the
Nail polish.
cutics. Cutics. Kasi acetone is used to make shabu. So, siya? Ingredient siya. So, included siya sa mga chemicals na gina-regulate sa PIDEA. So, ang correct answer jud aning number 3 class kay organic solvents. So, mana-appeal dira si acetone. Yeah, it can also be decahydronaphthalene or chlorinated solvents. Most likely, dapat organic solvents. Kasi, remember, these are grease. Oil, lipid siya kung matawag. Under siya sa lipids. So, sa chemistry, di ba, like dissolves, like you cannot mix water with oil, therefore you cannot use it to clean the grease. So dapat katong kapareho niya, meaning organic solvents. Again, organic solvents like acetone, ketone, ether, you can use that to remove the grease. Kaya lang ether is very volatile. So paspas kay siya mag-volatilize, lisod po siya gamiton. Katulad mga acetone, pinaka-common. What is the importance of marking the laboratory ware during an experiment? Why is it important to mark our glasswares? This one is very basic. Sa laboratories class, we always do replicates or we always do trials. Replicates ang tawag if we have the same sample and then we use the same procedure and we do it at the same time. We call it replicate. Pero if it's the same sample, the same procedure, but different time, meaning unya pa nimo i-test ang isa o kaya ugma, we call it trial. Ha? We call it trial. That's the difference between replicates and trials. So sa laboratory, we do trials and we do replicates. Now to avoid mix-ups and errors and to avoid confusions, then we have to really mark our laboratory ware. Our glasswares actually have meron siyang portion wherein we can write markings and then we have to use either pencil or kana mga semi-permanent na markings just to not mix up chemicals and for easy identification of chemicals. So yun yung answer ng ating assignment. These again are basics in the laboratory. So kailangan alam nyo yan kasi third year na kayo. Kasi hindi ay mahimo mong analyst puhon. Wala ta kabalo. Mag-record kalimot ko. We are talking about quality sa QC. So, kailangan calibrated atong mga ginagamit na mga aparatus, mga machines or equipment. So, the maximum capacity of at least 1 part in 10 raised to the power of 5 na precision sa ato ang analytical balance dapat. Kailan atong analytical balance sa school, dili siya makalibrate. Hindi na gid mo balik sa tunga ang iyahang bilog. Kita mo atong bilog, no? That's the mark na atong tandaan na calibrated jud o naga-function og tarong ato ang analytical balance. Though we also have less accurate na mga balances sa laboratory natin, ginagamit na tong kilohan sa murag kilohan sa karne mas ginagamit sa palengke katong iyang naong parehas ato, less accurate lang to siya. Ug katong uban pa na mga balances na ginapagamit nila sa lab. Pero pag abot sa QC, it's a no-no. Bawal jud to siya gamiton. Pwede lang gid nato gamiton sa QC kay analytical balance. So sa procedure, I want you to draw the analytical balance. You have to label its parts and indicate their functions. I want you to draw the electronic analytical balance. Kay naatay klase-klaseng analytical balance class. But again, I want you to draw the electronic analytical balance. Next, you have to describe sa activity ha. You have to describe the following: macro balance, semi-micro analytical balance, micro analytical balance, single pan analytical balance, and then the last one, electronic analytical balance. So let's get acquainted with the different types of balances. Next, we have weighing techniques. So in your activity, you have to discuss the following. How are we going to do the following techniques? First, weighing by addition, and then next, weighing by difference. So, mo na inyuhang himuon this afternoon. And weighing error. So, sa activity na I have placed here experimental procedures. And then I have also included the results of the experiment since we cannot do this inside the laboratory. So, i-include ko na yung result. And then all you need to do is to discuss your observation in the procedure. At the same time, you have to discuss what you have observed from the results given. Okay? The same thing, mga errors, mangguni siya weighing error. So the first one, effect of temperature. And then the second one, effect of moisture gain or evaporation. The same thing, procedure is given as well as the results. All you need to write is the observations. And then, effect of electrostatically charged weighing materials. Meron din siyang effect sa pag-weigh, pagkuha ng tamang weight. And the last one will be the buoyancy error. So when you say buoyancy error, nade-develop ito when the object na wini-weigh natin has a different density with that of the standard weights. Especially if we don't use the electronic na analytical balance. Though we can also compute for the buoyancy error, pero common ito sa single pan analytical balance na may mga weights kasi sila inside. However, there are instances na the weights na naa sa ato ang weights nato na naa sa ato ang analytical balance dili sila pareho og density sa object na ato ang ginaway. Therefore, we have to correct the mass of the object. So how do we correct this? We have the formula W1 equals W2 plus W2 times density of air divided by density of object minus density of air divided by the density of the weights. Buoyancy error is caused by air. Kanang na-effect ang air dito sa weight sa imuhang object. So, kailangan nato siya i-correct. So, when you say W1, that is the corrected mass of the object. I-correct nato siya. Though, nakita nato siya when we weigh the substance. So, dili pa to siya mauyang tinuod na weight kay tungod na ay buoyancy error na ginatawag. Okay? And then, again, that is mostly caused by air or the medium nga kung asa na ito gibutang atong object. And then W2 is the mass of the standard weights that will be given in the problem. And then density, DOBJ is the density of the object. And DWTS is the density of the weights. Now, ang density ng air is given. This is constant. We have 0.0012 grams per cubic centimeter. So, sa activity, na isa ka problem dinhi na kailangan ninyo i-correct ang mass. Now, you have to show the solution. So, nadiray nakabutang, a bottle weighed 7.65 grams empty. And then, tong gibutangan na siya og object, nahimo na siya 9.97. Okay? The density of the object is 0.92 grams per cubic centimeter. Now, the balance, nagigamit na siya weights. Stainless steel na weights. The density of the stainless steel weights is 8.0 grams per cubic centimeter. Now, you have to correct the mass of the sample for the effects of buoyancy using the formula above. So, try ninyo siya og solve. And then afterwards, please answer the guide questions, the conclusions, and write your references also. So, this will be your activity this afternoon. Kay na this 4 o'clock pa man, you still have 2 hours to answer this. I guess that's enough na ma-answer ni. And then group 1, sige tong group 1. Amil, Beles, and Pilio, you will be reporting.
Yes, ma'am.
You will be reporting tomorrow sa inyong answers sa activity number 1. Okay? Wait lang. I want this handwritten kay basta handwritten man good, mas may nag-retain sa inyong brain kaysa sa gi-copy paste lang ninyo siya. So I want this handwritten again. So pwede na mo mag-start kay sayang ang oras. Gamito na to atong time kay kung dili na ko gamito na tong time, I think daghan pa maghimuon sa uban nga subject. So ang time mismo na to atong gamiton to answer the activity. Pwede ninyo ni siya i-print tapos ang answer lang handwritten. Okay? Ang drawing, masabtan man ang drawing as long as kanang naong siya electronic analytical balance na. Okay, do you have questions before tayo mag-proceed with the activity? I will not turn off the